Hello and welcome back to LFI Educates. Hope all of you are doing fine. Today we are going to start the first chapter of grade 10 mathematics, that is real numbers. What is a real number? You might be thinking what it is. Numbers are basically classified into two types. One is called real number and the other one is called imaginary number. Imaginary numbers are those numbers which contains the imaginary part a plus ib. In this form, if I write like 7 plus or minus I3, then these numbers are called imaginary numbers, and these imaginary numbers are going to study from class or standard 11 onwards. But now, till now that you have been studying the numbers from lower classes till grade 10th, those numbers are all real numbers like rational number, irrational number, whole number, prime number, composite number, then even number, odd number, whatever numbers you have been studying from small class till now, these all numbers are called real numbers. In this chapter, real numbers, you are going to study about Euclid's division lemma, this is also not a new thing to you. You have been doing this dividend equal to divisor into quotient plus remainder. This comes under this Euclid's division lemma. Lemma is a statement which does not require any proof. Without proving also you know that it is correct. That type of statement we call it as lemma. As an example, sun rises in the east. Then you already know this. You don't have any. You don't require to prove it. So, statements which does not require any proof, that statement we call it as lemma, and this is your Euclid's division lemma. But due to this pandemic, this portion is eliminated from your chapter. Now, the second thing that you are going to learn is about fundamental theorem on arithmetic or of arithmetic. That will be discussing in exercise 1.2. Now after that, we'll revisit those irrational numbers that you have learned, root 2, root 3, root 7, 2 plus root 3, 1 by root 2, 1 by root 3. Those things we'll be doing in the third exercise, that is exercise 1.3. That will be revisiting the irrational numbers. That will be doing in exercise 1.3. And lastly, we'll even revisit those rational numbers, the numbers that are of the form p by q, where p and q are integers and q is not equal to 0. That also you are going to revisit in exercise 1.4. Revisiting rational numbers. So these are the things that you are going to do in the first chapter, that is real numbers. So to begin with, let us see this fundamental theorem of arithmetic first. The fundamental theorem of arithmetic, to understand, first of all, you should have a clear picture about prime numbers and composite numbers. So first let us discuss about prime numbers and composite numbers. Now we are going to do fundamental theorem of arithmetic. As I said, first of all you have to know about composite numbers Composite numbers are those numbers which has a factor 1 and itself as well as any other number as its factor. Those numbers we call them as composite numbers. Like suppose say example 9. 9 we know that it is divisible by 1. 1 9 times is 9. Completely it is divisible by 1. We even know that 9 can be divided by 9 itself also. 9 ones are 9. Then no remainder. So it can be divisible by 1 and itself, as well as it can be divisible by other numbers. Like 9 can be divided by 3 as well. 3 3s are 9. So as it can be divided by 1 and itself, as well as it can be divided by any other number, this number we can call it as a composite number. Or say 16, 27. These are some examples of composite numbers. Now when we talk about prime numbers, then those numbers which can be divided by 1 and it can be divided by itself alone, those numbers we call them as prime numbers. Example say 2. It can be divided by 2, I can divide by 1, and 2 I can divide by 2 itself also. 2 ones are, sorry, 1 2s are 2, 2 ones are 2. So we can divide only by 1, and by itself we can divide. With 2 we can divide. We cannot divide by any other number. So this number will come under prime numbers. Say 3 is under prime number, 5 is under prime number, 7 is under prime number, and so on. So the numbers which are divisible by 1 in itself, those numbers we call them as prime numbers. Now you must be careful here. You need to note one thing. 1, this number 1 is neither prime nor composite. 1 is neither prime nor composite. Then the smallest prime number that you can have is 2, and the smallest composite number that you can have is 4. 4 is also a composite number, 6 is also the composite number, but this is the smallest composite number. Now let us look about this fundamental theorem of arithmetic. I hope it is clear. The theorem says like this: every composite number can be expressed as a product of primes. And this factorization is unique, it says. This factorization is unique of the order of the primes in which they occur. Let us see nicely. Every composite number can be expressed as a product of primes. Like suppose say 64 or say 36. 36 you can express like this. If you find out its primes, 3 1s are 3, 3 2s are 6, 3 4s are 12, 2 2s are 4. So it is occurring as 3 into 3 into 2 into 2. So here you can see all the numbers are prime numbers. This one you can. So this 36, it was a composite number, and then when you found out its factors, it is coming in this order as a product of their primes. That is your theorem of arithmetic. Then this factorization is unique of the order of the primes in which they occur. Here it says that the occurrence can be like this also. This one you can write it as 2 into 3 into 2 into 3. Doesn't matter. There is also same thing. There's 3 square into 2 square. Or you can even write 2 into 2 into 3 into 3. That is 2 square into 3 square. That doesn't matter in which form they occur. Then positions can be interchanged because we know that multiplication is commutative. Now when you look your text, you will get a question like this. Express each number as a product of its prime factors. Now the first one that you can see here, 140. Then what you can do is 140 you write down. Then with 2 you can start. 2 7 times is 14 and this is 0. This 70 now you can do with 2 again. 2 35 times is 70. Then again this 35 you can do with 5. 5 7 times is 35. So like this you can find out the product of its primes. 2 into 2 into 5 into 7. So you write down like this the product of the primes of 140. It is 2 into 2 into 5 into 7, or you can write 2 square into 5 into 7. This way of finding out the factors, we call it as factor tree method. Or you can even do this way as well, alternative way. 140 you can write down, then find out its factors this way. 2 7s are 14, 2 35s are 70, 5 7s are 35. Like this also you can find out the product of their primes. Then you can write down the answer. The product of the primes of 140 is equal to 2 into 2 into 5 into 7, or 2 square into 5 into 7. Either of the way you can follow. Which one you like, you can follow the way. So let us see the second question. Here in question number 2 you can see find the LCM. LCM means least common multiple, and HCF, highest common factor of the following pairs of integers. They have given 2-3 sets of pairs. One I have written down here, number 1, 26 and 91. This is one set of numbers. Verify that after finding out the LCM and HCF, you have to verify that LCM into HCF, if you multiply LCM and HCF, that must be equal to the product of the two numbers. So here let us see the first question. First of all, what you will do is you find out the product of the prime factors of 26. You write like this: 26 is equal to, you can find out 26, 2 1s are 2, 2 3s are 6, 2 into 13 is 2 into 13, and 91 is equal to 91. You can do it by 7. 7 ones are 7. 7 threes are 21. So you write 7 into 13. In finding out the HCF, what you have to do is, which is the highest common factor, which terms are common, that you have to find out. These 2, 7, they are not the same. 13, 13, they are having the common factor. So this one you will choose it. This will give you your HCF. So you write HCF is equal to 13. And then you will find out LCM. When you find out LCM, the least common multiple, then this 13, the HCF what you have taken, you will take it, and the other numbers that you did not take earlier, other prime 2 and 7, 2 into 7. So if you multiply them, you will get the LCM. 13 2s are 26 into 7. 26 into 7, 42. 14 plus 4 is 18. This is 182. This way you can find out the LCM and HCF. First HCF, the highest common factor, and LCM, the HCF what you got it, multiplied by the other numbers that you didn't take it earlier, then you have to multiply them. Now let us see the second part, that is verify that LCM into HCF. So I'll write here verification. When you do verification, you can take LHS, RHS, or first you do these two and then you do these two, and so that both are equal. So if I take LHS and RHS, or straightway if I take LCM into HCF, multiply them. LCM we got 182 and HCF we got 13. If you multiply them, you will get 182 into 13. 3 2 times is 6, 8 3s are 24, 3 1s are 3, plus 2 is 5. 2, 8, 1, 6, 6, 13, 3, 1 in hand, 2. 2, 3, 6, 6. 2, 3, 6, 6. The next step, what you do is, you will find out the product of two numbers. Product of two numbers. Numbers means the given numbers. The given numbers are 26 and 91. So 26 into 91. Do 26 into 91. 91 into 26. 6, 9, 6 are 54, 2, 18, 6, 6, 13, 3, 1 in hand, 2, 2, 3, 6, 6. Then you look here, are they equal or not, you will see. LCM into HCF is exactly equal to the product of two numbers. Thus, or hence, LCM into HCF is equal to product of two numbers, hence verified. And this way you have to proceed. You have to solve the questions. Then let us see the next one, that is question number 3. And here one more important point is that you have one formula also. From here you get one formula. LCM into HCF is equal to product of two numbers. We can use this as a formula. Some numericals we'll solve and see. Also in question number 3, we have to find out the same LCM and HCF for the following integers by applying the prime factorization method. Now in this case also you will follow up the same thing. First of all, for 12 we'll find out the product of their primes. 12 is 2 into 3. 2 2s are 4, 4 3s are 12. Then we write it as 2 square into 3. Then 15, you can write it as 3 into 5. and the third number, that is 21, it is 3 into 7. Like this you can find out the product of their primes. After that you can find out their HCF. You can even write like this also of what? The three numbers 12, 15, 21. This way also you can write down. You are finding out the LCF of this, HCF of these three numbers. Then here the highest common factor is 3. Here also you have 3, 3. So you can take this as 3. Your HCF will become 3. 5 doesn't occur here. 7 also doesn't occur in these two places. So you can neglect it. You will get your HCF. After that, LCM. LCM of these three numbers 12, 15, 21. You can write down first of all the HCF, take it 3, and the numbers which you did not take earlier. This is 2 squared, it is 4, and then 5, and then 7. If you multiply them, you get the LCM. 4 5s are 20, 7 3s are 21. 20 into 21 is 420. It will be 420. That will give you your LCM. But one thing is to be noted, that if more than two numbers, if it is given to you, then you cannot use this relation. LCM into HCF is equal to product of three numbers. If three numbers are given to you, they are not equal. It's only, this formula is only applicable, the last question that you have done, only applicable if two numbers are given to you. LCM into HCF of two numbers will be product of the two numbers. That is to be noted. Let us see next question again. Question number 4. Here given HCF of these two numbers, it is 9. You have to find out the LCM of the two numbers. Now for two numbers, as I said earlier, you can use this formula. LCM into HCF is equal to product of the two numbers. So here LCM you are going to find out. HCF is given to you, it is 9. So equal to product of two numbers, it is 306 into 657. So from here LCM, if you want to find, then you will bring down this number. This division will become, multiplication will become division. 306 into 657 divided by 9. So 9 will come down. Then see if you can cancel it. 9 3s are 27. 3 6 9 4s are 36. So it is a product of 34 into 657. This is your LCM. So ultimately you can write down the answer. LCM of the two numbers. What are the numbers? 306 and 657. It's equal to, multiply whatever you get, that will be your final result. 34, 7 4 28, 20 plus 2 is 22. 24, 25, 26, 21, 2 in hand, 15, 16, 17, 7, 1 in hand, 18 plus 1 is 19, 8, 3, 13, 12, 2, 2, 2, 3, 3, 8, 2, 2, 3, 3, 8. Like this you can get the LCM. Sometimes they may ask you to find out the HCM, giving you the value of LCM. So you are going to use the same formula. LCM to HCF is equal to product of the two numbers. This way you can do it. One more question let me do. Let us do this question. Question number 5. Check whether any number raised to a natural number here, 6 to the power n, is given like this, but we can think this way. 6 to the power n can end with the digit 0 for any natural number n. So here what you have to know is this base quantity 6, if it can be expressed as a product of its prime number, that is 5, that you have to remember, 5, then that number will end with digit 0 for any natural number n. So this prime factorization of this base quantity will tell you, suppose this is 6. If I do prime factorization, 2 3 times is 6. So here 5 does not occur. If 5 does not occur, then this number will never end with a digit 0. That is to be remembered. You can do this one like this. 6 to the power n is equal to 2 into 3 to the power n. So here the prime factorization of 6 does not contain the factor 5. Therefore, 6 to the power n can never end with the digit 0 for any natural number n. So this way you can write down the answer. If its prime factorization gives you the digit 5 or contains the factor 5, then we can say that this number, if it is raised to the power with any natural number, the number will end with digit 0. Now, question number 6 and 7 that you can try at home and send it to me through WhatsApp. Two numbers are given in question number 6, just to check it why it is a composite number. And as I have already said to you, a composite number is a number which has the factor 1 itself and any other number. If you can find out that any other number is divisible with any other number, the number can be divisible or you can divide it, then that number will be called as a composite number. That one to explain. And then the next question, that is question number 7, that is to find out the LCM. Two persons, they are running in a circular track at the same time, but both of them takes a different time interval to complete the path. So if they run from the same point at the same time at different speeds, then after what time they will come and meet each other. That means what is the least time they will require to meet each other. So you have to find out the LCM. Try to solve it and I can check it through WhatsApp. Thank you and have a nice day. So in the next video we'll start the second exercise, or we'll have to say just the third exercise, that is exercise 1.3, that revisiting irrational numbers.